welcome back to another M&S tutoring video, and in this video we're going to be beginning our second unit in grade 10 math, quadratic relations. Today we're going to be learning about the base parabola and how A affects the steepness and the general slope of the parabola. So let's get started with the base parabola. The base parabola is modeled by this general equation of y is equal to x squared. What does this equation even mean, and what does that have to do with the different transformations of the base parabola? Well, in this video, I'm going to show you how the base parabola becomes more steep, how it becomes more flat, and how it becomes a positive slope, and how it changes to a negative slope. So let's start with the base parabola itself. The base parabola is graphed using a table of x and y values with a finite first differences of 2. So if x is -3, -2, -1, 0, and so on, y will always be that of x squared. So in this case, y would be 9, 4, 1, 0, 1, 4, 9, and so on and so forth. So as we now know, this is the table that portrays this parabola on the left. How do we actually make this parabola on the graph itself without actually knowing the coordinates of this parabola, of the base parabola? Well, you have to look at the shift step. The shift step is something that tells you where the major points on the parabola are going to be. So right now we know that the parabola starts at 0, 0, as it is the base parabola. So that's a point that we can mark on the graph. Now that we know that, the base parabola shift step is always that of its finite differences. It's always the difference of the second differences, sorry. So if we look at the second differences on the y side, we begin to notice a pattern. So the difference between 4 and 9, of course, is 5. The difference between 1 and 4 is 3. The difference 0 and 1 is 1, and so on. 3, 1, 3, hold on, I think I made a mistake here. The difference between 0 and 1 is 1, not 3 actually. It's 1 over here, and then 1 again, and then over here we have it to be 3 and 5 over here again. So as you may already notice that the second differences of this are 2. So when we look at this, we know that the second differences always portray back to the shift step. So the shift step of the base parabola is you have to shift 1 and you have to step 1, right? But the shift 1 always stays the same, but after the first shift 1, step 1, you have to step 3, right? And after that, it's the same thing, you have to step 5. And as you notice, the parabola gets steeper and steeper as you have to step plus 2 each time, just like the second differences. So if you guys don't really know what I'm saying right now, I can help you visualize it even better with the parabola itself. So as you can see, as you start on 0, you have to shift 1. So you go into 1 over here, and you have to step 1, right? Now that you're on your second shift step, you have to shift 1 again, but you have to step 3 this time. So 1, 2, and 3, right? And so on. Now you have to shift 1, and you have to step 5. 1, 2, 3, 4, and 5. And that's how you make the points on the base parabola. After you have the points, all you have to do is you have to draw a smooth line that connects all of the points to make your parabola. So that is basically the shift step of the base parabola. Now, what is A? Many of you, if you've noticed, the base equation for a parabola is y is equal to ax squared plus bx plus c. Well, what does the a do? The a actually affects the steepness of the parabola. So a determines the steepness of the parabola as well as the way it opens. To get a new shift step, you simply just multiply a to the given shift step. So say for example, a is 2. To get your new shift step, you would have to multiply 2 by 1, 3, 5, 7, and so on. And you would get your shift step for your parabola. So your new shift step would be 2, 6, 2, 6, 10, and 14. So for a parabola, when the a value is 2, you would no longer have to shift 1, shift 1, step 3. Now you would have to shift 1, and step 2. You have to shift 1 and then step 6. To shift 1 and then step 10. Notice how the parabola will become steeper than our previous one, as you have to shift the same amount, but you also have to step a lot more. That is how the parabola is transformed to become more and more steeper. Now, what if a was a fraction rather than a whole number? So let's say a was a 1.5, right? You would do the same thing. You'd multiply it to the base shift step, which was 1, 3, 5, and 7, and so on, right? And just remember, I'm showing you the 3 dots because you could continue the parabola forever as it's infinite. But to make like that general parabola shape, you would only have to do it to maybe the first 3 or even the 4. So if you have a fraction, you have to do the same. You have to multiply it by each one of the step numbers. So you would get 1 over 2, 3. Sorry, no. It'd be 3 over 2. Hold on. Made a mistake here. It'd be 3 over 2 and 5 over 2 and 7 over 2, right? So it'd be the same thing. You'd be shifting 1, but you'd be stepping only a half, right? You'd be shifting 1, but you'd only be stepping 3 over 2. You'd be shifting 1, but you'd only be stepping about 5 over 2. So as you notice, the parabola becomes a lot less steep because you're stepping a lot less than you're doing to the base parabola. So how can we make it easy if we don't want to, usually use a fraction when we're graphing? What you can do is you can combine 2 of the shift steps. You can say, I want to add both of these fractions. Say 1 over 2 plus 3 over 2, right? Which gives us 4 over 2 or 2, right? Since we combine 2 of them, now we would have to step 2, but we could also shift 2, right? If we don't want to work with a lot of fractions here when we're graphing. We could do the same thing to the other 2 fractions. We could add 5 plus 7, and we could simply just do the same thing like we did before and get a step 2 and shift 12, right? It's really that simple. All you have to do is combine the fractions to see where to graph the points of the base parabola. So now what if a is negative? Well, if a is negative, you just have to remember that you have to shift downwards. So as if a is positive, you're stepping up, right? But if a is negative, then instead of stepping up, you're gonna step down. So you're still gonna shift the same direction. You're gonna shift 1 to the left or the right. It doesn't really matter. But now you're gonna step down, right? You're gonna step down how many ever you're supposed to shift, right? So the parabola would look like a frowny face, rather than a smiley face if it's positive. So you have to note that when a is a number greater than 1, the parabola will grow at a faster rate, vertically stretching the graph. So when a is a larger number, greater than 1, the parabola will look more like this. It will be more steep. But when a is a number between 0 and 1, if it's a fraction, right, the graph will increase at a slower rate. This will vertically compress the parabola, making it look something like this, right? All you have to remember in this is that A always shifts the base parabola. Other than that, this video is a really basic general idea of what A does to the parabola. In our next few videos, we're going to be learning how the parabola is shifted to the right and to the left. Other than that, thanks for watching this video, guys. If you have any comments or concerns, please feel free to leave it down in the comments below, and I'll get back to you as soon as possible.